Hello, I'm Stéphane Farou, a French database consultant, and I've designed this short video note about SQL Joins. You probably know what join is. In a relational database, when two tables have one or several common columns, you can link them by saying that a row in one table matches a row from the other table that has the same values in the common columns. For instance, you can store in your database the registered members of a website. They are identified by their screen name, and a numerical ID is used as a convenient reference. Your table probably contains more information, such as the date when members joined, and perhaps a number of points acquired by providing useful answers in a forum. Another table will contain the messages posted by members on the forum. I've just shown here the member ID and the subject of the post. You would obviously also have a date, the message body, and possibly some other information. If we want to list the messages, most recent first, we also want to display who posted the message, as well as the members' points. We will therefore write a query such as this one, in which the member ID column in the messages table refers to the member ID column in the members table and is used to perform the join and get the required information. When you are taught SQL, you are often explained that the operation consists in generating all possible combinations between the rows from the members table and the rows from the messages table to only retain the combinations for which the common column contains the same value. This operation is called the Cartesian join, after René Descartes, one of the major European philosophers and mathematicians of the 17th century. Although a database system sometimes executes Cartesian joins, the most common ways to perform a join are nested loops and hash or merge joins. To explain the difference between those two categories of joins, Tom Kite, who is senior technologist with Oracle, once used an excellent analogy on his popular Ask Tom site. I've tried to illustrate Tom's dance floor analogy. Here is how it goes. Suppose that you have a few guys and a few girls. Each guy is looking for a partner of about the same size as himself. The first guy moves forward and is strongly attracted by a girl who looks like a model. Unfortunately, models are tall and our guy is rather short. A second girl is quite lovely, but a tad too tall for him. Finally, he finds a suitable partner who has both the right size and a nice smile, and invites her. If each guy repeats the same process, we have in effect the same algorithm as with the nested loop. Now, suppose that we have a lot of girls and a lot of guys. If we take the same Goldilocks approach to flirting as before, it is likely that dawn will be there before all couples are formed. Therefore, we are going to trade romanticism against efficiency and ask all girls and all boys to get in rank by order of size so that we can easily match them. This would be an overkill with very few individuals, but with a large number of people, this is probably the best way to proceed, and it is exactly the way a merge join works. In the dry world of databases, to perform a nested loop, an SQL engine will scan the smallest of the two tables, then find in turn the matching rows in the other table. It is very important that the column used for the join is indexed in the bigger table, because otherwise you would have to scan it each time you consider a new row in the smaller table. We have seen how merge joins work. Hash joins are a variant that is a good compromise in terms of CPU and memory usage. In a hash join, a temporary hash table is created. A hash table is a kind of array that contains pointers to the rows of a table. A special function, called the hash function, applied to the key, associates each key to a position in the array. The smallest table is scanned first, and the hash table is populated with pointers to the rows that match each key. Then, the second table is scanned only once, the function directs us to the proper slot in the hash table, and from there, you find the pointers to the matching rows. Contrarily to the nested loop join, indexes are no longer so important. An SQL optimizer may choose to scan an index rather than a table because indexes are usually smaller than tables, but this is a marginal improvement. When the query isn't madly complicated, when data statistics allow to get a fair idea about the expected size of the result set, and if existing indexes allow a choice, the query optimizer can usually decide which type of join will be fastest. If the query is really complex, the way you write it often sends signals to the optimizer. But that, as Kipling used to say, is another story. Thank you for listening.